All right, so reviewing factoring. So when you were taught how to factor, first thing you were taught was your Gcf factor, because that is always the kind of factoring you should look for first. So you should look to see if you have Gcf factoring. If you do, you want to take care of it. After Gcf factoring, it breaks off into two types. If you have two terms, you want to look to see if you can do your dots factoring with that, which would be a difference, so it needs to be subtraction, and it's got to be perfect squares. That's how we know it's a dots factor. After your Gcf, if you have three terms, that's going to be our trinomial factoring, where we do our check by doing our little smile, big smile to see if we get our middle term. Now, if you have 4 or more terms, you're going to factor by grouping. And then my other little note for here is factor completely is always implied. They never tell you to do it. You need to know to do it. So factor completely means sometimes we have to factor more than once. So that's what we need to look for. Let's look at our examples. So looking at example A, do we have a Gcf there? Nope. But we got how many terms? 3. So this is going to be our trinomial. So I'm going to set up 2 sets of parentheses for my trinomial factor. Will our signs be the same or different? Different. So we're going to have an x minus and an x plus. And then we're looking for what multiplies to give us 18, but will give us a 7 in the middle.
9 and 2.
9 and 2. 9 should be my negative. 2 would be my positive. Again, if you need to do a check, you multiply those 2 little inside terms. That's our little smile. Multiply those 2 outside terms. That's our big smile. And we get what our middle term is, which is negative 7x. That means we did it correctly. All right, so letter C. Do we have a Gcf?
Yes.
Yes. What is it?
6.
6. So I pull out my 6. I'm left with x squared minus 4. Now, x squared minus 4, is that a dots? Yes, because we got a subtraction, and x squared is a perfect square, and 4 is a perfect square. So I leave my 6 on the outside, set up my 2 sets of parentheses. How does x squared minus 4 factor? X plus 2 and x minus 2. So letter D, do we have a Gcf? No, but we got 3 terms. That tells me I'm going to do a trinomial factor, so I'm going to set up my 2 sets of parentheses. This one's a little different than the first one, because 5x squared, how do I have to break that up?
You just do 5x and then 3x.
Yeah, 5x and 1x. Will our signs be the same or different?
Different.
Different. And what multiplies to give us 8? We get a couple of choices. 2 and 4. These ones you definitely want to do your check to make sure you have them in the right places. My little smile would be a 2x. Big smile would be a negative 20x. Combine those, I get a negative 18x, so I happen to get it on the first try. That would be my answer. 5x plus 2 times x minus 4.
So when it says factor, you can do like that, but when it says solve,
You would keep going and you'd set them equal to 0. But yeah, no, these ones are just factoring. All right, so I want you to try these 3 down here on your own. Does anybody think they have the rest of E? What numbers do we want to use for 8? 8 and 1. 8 there, 1 there, because then your little smile's a negative 16x. Big smile's negative 9x. So that would give you your negative 25x in the middle. So that's our answer for that one. So down below, we have our factor by grouping review. I want to look first at the last three, C, D, and E, and then we'll go back up to A and B. So when we're factoring by grouping, remember you group terms together. So like in letter D, I'm going to group the first two terms. I'm going to group my last two terms. What would be our GCF in our first parentheses? X squared. So I would be left with 3x plus 2. Our GCF in the second parentheses? Negative 9. And then it would be 3x plus 2 left. Because the parentheses are the same, remember that's how we know we did it correctly. So now we're going to take the parentheses, write it out in front. And then in another parentheses you write what's left, which would be our x squared minus 9. So 3x plus 2 times x squared minus 9. Can we factor x squared minus 9 again? Yes. So it would be x minus 3 times x plus 3. So we have 3 sets of parentheses in our final answer for that one. So for D, again, I'm going to group my first two, group my last two. What's our GCF in the first two? Yeah. So I take out my 9x squared, I'm left with a 2x plus 1. What's our GCF in the second set of parentheses? Negative 1. So then I'm left with 2x plus 1. So then we put our 2x plus 1 first. And our second set of parentheses is 9x squared minus 1. So then you have to ask yourself, can we factor 9x squared minus 1 again? Yes. That one's a dots again. So 2x plus 1 times 3x minus 1 times 3x plus 1. So let's have you try letter E. So I got x plus 2 times 5x squared plus 20. Can we factor 5x squared plus 20 again? Yeah. How are we going to factor that? GCF. What's the number I can pull out of there? 5. So 5 times x plus 2 times x squared plus 4. And that's our final answer. A lot of people think you can factor x squared plus 4 again, but you cannot. It's got a plus sign, not the minus sign for dots. So it looks very dots-like, but it's actually not. So I do those 3 first, and then I go back up to A and B, because A and B, all they've done is they already did the grouping part for you. So they got you to this step. So what do we do after that? Take the stuff from the parentheses, yep, put that out in front, and then x plus 7 afterwards. But sometimes without doing the other examples first, people don't always see that right away, that they've already done the grouping portion for you. So in letter B, that one was a little bit more complicated, but again, they've already done the grouping for you. What's the common one? X plus 4, so that goes out in front. And then we have 2x plus 8 minus x minus 2. That's the tricky part for that one. You have 2 binomials in that second set of parentheses that you then need to combine your like terms for. So I'm going to distribute the negative sign. So I have negative x, positive 2. So 2x minus x would give us an x. 8 plus 2 would give us a 10. So then we get our answer, x plus 4 times x plus 10 for that one. All right, so for our last page of notes, these are kind of some funky factoring ones. Some people refer to the first kind that we're going to do as chunking, because if you look at x plus plus 5 squared minus 4 times x plus 5. A lot of you are going to look at that and you're going to do that a much more difficult way than you need to do. What you can do for this is, since that's x plus 5 and that's x plus 5, I'm going to pick a letter. So I'm going to pick the letter A. And I'm going to say A equals my x plus 5. So then what I do is I substitute A in for my x plus 5. So I get A squared minus 4A. And now what I've done is I've created it into a simpler problem, and you guys are able to see a little bit easier what kind of factoring we're going to do. GCF. What is our GCF going to be? A. It's A. So then we're left with A minus 4. Can we factor that any further? No. So I'm going to go and replace my A's back with my x plus 5. So I'm left with x plus 5 minus 4. So then over here in my second parentheses, we just got to combine our 5 and our 4 for our final answer. So we get x plus 5 times x plus 1. And that's our final answer there. So if we look at the next one, again, that one looks pretty tricky, but we're going to pick a letter to substitute in. We can use x for the next one because they didn't already use x. You want to use W? So I'm going to say W equals 1. Guys, knock it off. So W equals A plus 1. So I'm going to replace this as 4W squared plus 12W minus 40. So again, we've now created it into a simpler problem for us to be able to factor. Do we have a GCF?
Yeah.
Yes. What is it? 4. So I'm going to pull my 4 out. I'm left with W squared plus 3W minus 10. So inside of our parentheses, what kind of factoring do we have now? Trinomial. So we're going to have a W plus and a W minus. And then what multiplies to give us 10? 5 and 2. Which one would be our positive? 5. And there are 2 here. So then again, we just need to go back, because we factored this as much as we can. We need to go back and plug in our A plus 1. So this would be A plus 1 plus 5, and A plus 1 minus 2. And then just combine your numbers. So we have 4 times A plus 6 times A minus 1. There is another way you could factor that, but that way it's going to take so much longer. So just plugging in and replacing that with one letter, it's going to make your life a little easier. So our next one, we're not going to do any grouping with that. We're not going to do any chunking. It looks like it's set up for what kind of factoring? Factor by grouping. So we have 4 terms. But these first 2 terms, do they have anything in common?
No.
These last 2, anything in common? No. So I'm going to rearrange these. I'm going to bring the AX up here with my x squared. So I have x squared plus AX, because they would have a common term of x that I could take out. And then I'm going to put my minus CX minus AC, because then those would have a common term of C that I could take out. So now we can do our grouping. Our GCF here we said was x. So I would be left with x plus A. Our GCF in the second one would be what? Negative C. Then I'm left with x plus A. So in our final answer, we would have x plus A times x minus C. So that one was just a little bit different because we had to rearrange our order a little bit. That one in the middle there should look pretty familiar to you. This one was on your last algebra set. Even though there's 6 terms, you still want to group them in groups of 2. You're just going to have 3 groups of 2. So what would be our GCF in those first 2 groups, or in that first group? K squared. And then I would be left with k squared minus 4. Our GCF in our second group, 8k. And then again, we're left with k squared minus 4. And then our last GCF, 12. So again, just like our other grouping, we know we've grouped it correctly because your parentheses all have the same thing in there. They're all k squared minus 4. So I'm going to put that out in front. We would be left with k squared plus 8k plus 12. All your GCFs go together. And then we factor each of those again. K squared minus 4, that's a dots factor. K minus 2. K plus 2. Our other one is what kind of factor? Trinomial. Our signs would both be positive. What multiplies to give us 12 adds to 8. 2 and 6. Now you could leave your answer just like that. Does anybody know the other way we could write our answer though? Yeah, k plus 2 squared. And then our k minus 2 and our k plus 6. So either of those two would be right. I like to show you both just in case you happen to have a question like this as a multiple choice. You might get this first answer here, but they have it written as a second answer as a choice. So you got to make sure you understand that those are the same thing. All right, and then our last one in our funky factoring. Does anybody see anything in common there? We got an A here, but there's nothing really for that one, so we don't want to do grouping. This one's a little different. If I look at these first 3 terms, is that a trinomial that I can factor? Yeah. So our first terms would be a's to get me my a squared. What would our signs be? Both positive. And then what multiplies to give us b squared? B times b. So then again, just to refresh our memories, to get that 2ab in the middle, if I multiply my inside terms, I'd get an ab. Multiply my outside terms, I get plus another ab. So that's how we get our 2ab for our middle. So now a plus b times a plus b would be a plus b squared minus 16. Can anybody see what kind of factoring that would be? Okay, let's try this. I'm going to use just the letter x as my a plus b. So if I rewrite that as x squared minus 16, what kind of factoring do we have? Dots. So that's why we like to rewrite them, because then it makes it a lot easier for you guys to see what you need to do. So that would factor into x minus 4 times x plus 4. So then we just have to go back and put in our a plus b. So a plus b minus 4 times a plus b plus 4. You just got to practice that. That's the only way we're going to get those ones. So then our completely and totally brand new kind of factoring we're going to do for today is your difference in sum of cubes. But the main thing here is that they are perfect cubes. So they look a lot like your dots problems, but instead of being perfect squares, they end up being perfect cubes. So we're going to write a couple of formulas for them. So a cubed minus b cubed, that's an example of a difference of a perfect cubes. So then a cubed plus b cubed, that would be an example of the sum of our perfect cubes. So what happens is there's one way to factor these and one way only. What you want to do in order to be able to factor them is you first have to take the cube root of your terms. So write yourself a little note, take cube root of terms. So now since our examples are just a and b, if you take the cube root of a cubed, you get just a. Cube root of b cubed, you get b. So the way this would end up factoring is it would start as a minus b, so your first term minus your second term, once you take the cube root of them. And then it's your first term squared plus the two of them multiplied plus your second term squared. And as we do examples, I promise that'll get a little bit easier. That's always the formula for when you're doing the difference of them. If you're adding them, it would be the first term plus your second term in the one parenthesis. Over here, it would be the first term squared minus the two of them multiplied, and then plus the last term squared. So the only difference between our formulas are just a couple of signs here. So you got to remember, if you're doing difference, it's minus and then plus plus. If you're doing the sum, it's plus minus plus for your signs there. Let's take a look at our examples. So we got y cubed, so I got to take the cube root of y cubed, and I got to take the cube root of 8. Those are our two terms. So when I take the cube root of y cubed, all I'm doing is dividing my exponent by 3. So I'd get y to the first. Cube root of 8 gives us what? 2. This is what we're going to use for our a and our b in our formula up above. So since this one is subtraction, I'm going to follow my first formula up here. So it starts with first term minus second term. So y minus 2. Again, it's after you've taken the cube root of them. Then it's going to be your first term squared, so y squared, plus the two terms multiplied, so plus 2y, and then plus the second term squared, so 2 squared gives me a 4. And then that's it. You're never going to be able to factor it any further than that. So let's try the second one. So again, I'm going to take the cube root of both my terms first. So what's the cube root of 1? 1. What's the cube root of 27? 3. And then our x, we would divide that exponent by 3, so we would just get 3x to the first. So again, using that formula up above, the 1 would be our a, the 3x would be our b. Again, this was a subtraction, so I'm using the first one up here. So it starts out with a minus b, so I would put 1 minus 3x. So inside the parentheses, looking up here, we start with a squared, so 1 squared would give me a 1, plus multiplying the two of them together, so 1 times 3x gives me a 3x. And then plus the second term squared, so 3x squared gives us a 9x squared. You got to square the 3 and the x. So that's our final answer for that one. All right, let's try it for example 3. So again, we got to take the cube roots first. So the cube root of 8 gives us what? 2. And then cube root of x to the 9th, x to the 3rd. So 2x to the third. And then the cube root of 125 would be 5. So 2x to the third would be my A when I'm using my formula. 5 will be my B. This time it's plus, so we're going to use our second formula down here. So it starts off with A plus B. So 2x cubed plus 5. So now I need to square my A. So if I square this, I get 4x to the 6. Got to square my 2. Also, you square your x to the third. And then it's minus, this time, multiplying these two together. So 2x to the third, or times 5, gives us 10x to the third. And then we end it with a plus b squared. So plus 5 squared, which is 25. And that's our answer for that one. So it's all about following the pattern for those ones. So you got to just memorize those patterns. I recommend making sure you write those on the top of your homework before you actually go and do your homework so you can keep looking back at them. We're not going to do that last one. Just a little reminder here. When you square x minus 2, you don't get x squared minus 4. You don't square each piece. Remember, you got to multiply it out. Same thing happens when you cube it. You got to remember that x minus 2 cubed is not x cubed minus 8.